Today we shall explore this interesting 18th century Sanskrit text on geometry called the Rekhaganita, or the Mathematics of Lines. Amusingly, it's a paraphrased translation of a translation of none other than Euclid's Elements. Before we understand how exactly Euclid's axioms and theorems are presented in Sanskrit, we should first delve into a brief history lesson. The Rekhaganita was composed in the kingdom of Jaipur, which was known for being a hub of astronomical and mathematical learning and home to a famous observatory that houses the world's largest sundial. Now, around 300 BC, Euclid writes the Elements, a comprehensive textbook on geometry from axioms to theorems. Then, during the Islamic Golden Age in the 8th to 4th century AD, Euclid's work was translated into Arabic and Persian with the famous rendition by Nasir al-Din al-Tusi. Finally, in 18th century India under King Sawai Jai Singh II, Pandit Samrat Jagannatha compiles and translates al-Tusi's text into Sanskrit. The Sanskrit geometrical terminology is rather interesting. A point is called bindu, a line called a rekha, an angle is called kona, with acute, right, and obtuse angles being called alpakona, samakona, and adhikakona. Parallel lines are called samanantara rekha, while perpendicular lines are said to be in the hanging form or lamba rupe. A triangle is obviously a tribhujam or three sides, and appropriately an equilateral, isosceles, and scaling triangles are called samatribahukam, samadvibahukam, and vishamatribahukam, or same three sides, same two sides, and distinct three sides. A quadrilateral is obviously a chaturashra or four-cornered. A square, rectangle, and rhombus are called samachaturbhujam, ayatam, and get this, vishamakona samachaturbhujam. Literally, they are same four sides, elongated, and oh god, different angles, same four sides. They really couldn't think of a shorter name? Now, here's where things get really interesting. In English, a line is marked by 2 points, A and B. We call this line segment AB. Well, in Sanskrit, that is, I kid you not, abarekha. An angle labeled B is called angle B, but in Sanskrit, bakorna. Is this even grammatically allowed in Sanskrit? Honestly, I don't even know if it is. They don't even apply the proper sandhi rules. Anyway, a triangle is unsurprisingly labeled with points A, B, and C, or in the Sanskrit text, a, ba, and ja. Wait, hold up, ja. That doesn't make any sense. How does C map onto the sound ja? Like a, ba, ka, or a, ba, sa makes better sense. Well, time for another history lesson. In the original Greek traditions, triangles were labeled as alpha, beta, and gamma, the first three letters of the Greek alphabet. And in Arabic, that is alif, ba, and jim. There it is. Now, if these names of the letters sound familiar, that is because they are related. They come from the Phoenician letters alp, bet, and gamal, or ox, house, and camel. These gave rise to the Greek letters alpha, beta, and gamma, which then gave us our Latin letters A, B, C, and also G. These Phoenician letters also gave way to the Arabic Abjad letters alif, ba, and jim. When Pandit Samrat Jagannatha was translating Euclid's Elements, he was working with the Arabic text by al-Tusi, so he saw alif, ba, and jim, and used similar sounding letters from the Indic scripts, a, ba, and ja, and hence we essentially have a linguistic telephone. Speaking of telephone games, the Rekhaganita is not really a faithful translation of the original Greek. Look at the first two lines. Yaf padartho darshana yogyo vibhaganarha sa bindu shabdavacha. Yaf padartho dirgho vistara rahito vibhagarha sa rekha shabdavacha. Or, that thing which is fit for seeing and unworthy of division, that is said to be with the word point. That thing which is long and barefoot of width and worthy of division, that is said with the word line. And what does the original Greek translate to? A point is that of which there is no part, and a line is a length without breadth. Wow, that's brief. But remember that this is not a literal translation, but more of a paraphrase. Now let us dip our toes into how Sanskrit was used to give geometric theorems. Here's an example. Yasyam nyasta bindavo lokita santa eka binduna chadita iva drishyante sa sarala rekha jneya anyatha kutila. Or, that in which nested points being observed are as if seen as covered from one point, that is known as a straight line, otherwise a crooked line. What does that mean? Well, consider a straight line being a collection of consecutive points. When you view it at an eye level from the side, the lines appear like a single point with the other points eclipsed. Now, consider a curved line. When you view that from the side, the first point fails to eclipse the other points and you see a line. Pretty neat. Now, let us get into a more elaborate theorem, how to construct an equilateral triangle. Tatra yada samatribhujam kshetram kartavyamasti tatra abharekha cha jnata asti tadupari tribhujam kriyate tadyatha. There, when an equilateral triangular region is to be made and there is known the line aba, upon that line the triangle is made. That likewise. Basically start with the line aba. Yes, I'll use the Rekhaganita labels. Now, kendram kritva aba vyasardhena vrittam karyam evam bham kendram kritva aba vyasardhena dvitiyam vrittam karyam. Having made the center, a circle with the radius of ba is to be made. Indeed, having made ba the center, a second circle with the radius ba is to be made. So make a center circled on point such that the radius is the line ba. Now do the same for the circle centered on point ba. Yatra vritta dvaya sampatas tatra jah chihnam karyam tatra ajarekha bhajarekha cha karya tatra abhaja tribhujam samana tribhujam jatam. Where there is a collision or intersection of the pair of circles, there the mark ja is to be made. There the line aja and the line baja is to be made. There triangle abaja, an equilateral triangle, is born. In layman's terms, at the intersection of the circle, label it as point ja and make the lines aja and baja. Behold, an equilateral triangle. Now we're actually given a reasoning for this phenomenon. Kutah atra abarekha ajarekha samana asti. Yato bhaja vrittasya vyasardham asti. Punar bhajarekha ba'arekha samana asti. Aja vrittasya vyasardatvat. Punarbhajam ajasamanam jatam abatulyatvat. Tasmad bhuja rekhatrayam mita samanam jatam. From what? Here the line aba is equal to the line aja because it is the radius of circle baja. Again, line baja is equal to the line ba'a from being the radius of circle aja. Again, baja is born equal to aja from equality to aba. From that, the triad of sidelines is born mutually equal. Simply put, the lines baja and ba'a are equal because they are the radius of the right circle. Lines aja and aba are equal because they are the radius of the left circle. Then lines baja, aja are equal by the transitive property, and since all three lines are equal, we have an equilateral triangle. This is very cool. And like so, you'll find many of Euclid's geometric theorems and proofs explained in the Rekhaganita in prosaic Sanskrit. And it's a testament to how advancing knowledge